Well, thank you for joining us today for a webinar on securing software supply chains. Good morning, good afternoon, and good evening, wherever you may be in the world. My name is Stan Wisseman, and I'll be your host for today. I'm the Chief Security Strategist for CyberRes here in North America. And joining me today are a great set of panelists. Kevin Greene, who is our Chief Technologist for our CyberRes Federal Organization, Emil Wåreus, co-founder and head of data science at Debricked, and John Keane, who is known as a software angel of death in assurance circles, software assurance circles here in the U.S. And each of us I'm going to give each of them a chance to expand on their backgrounds and the context of how to best secure software supply chains and some of their background there. But first, I want to get into the topic a little bit to help set the stage. The application security industry has been on a journey. I got started in this personally back in the early 2000s. We had the Gary McGraw touch points. We had the Microsoft SDL. We had a number of things that helped us understand the activities to inject into the software development lifecycle to help mitigate software vulnerabilities and weaknesses. But the pace of evolution rapidly has increased in the last few years. I mean, we're trying to keep up with modern development and their practices, and is causing change in how we actually apply things. And honestly, in the context of what we're talking about today, it's a challenge and complex issue as far as how we can actually address these risks and mitigations. The CyberRes Fortify research team has done a number of different papers over the years. In the last couple of years, we've had a report on security trends, and our 2022 trends report was just released. It reflects a number of different key industry trends that I think everybody that looks at this list would agree to is what we're sort of experiencing in some way or another. The first webinar in the series gave an overview of all these trends, and today we're focusing and doing a deep dive into securing the software supply chain. The diagram you see up here on the screen is representation by Google and their SALSA framework of different attack vectors. And, these issues and the things that you're seeing here as far as potential areas of concern aren't new. We've been talking about potential areas of concern around the acquisition of secure code, the potential attacks to our supply chains for quite some time. But what we've really lacked, honestly, to make significant change in how we are approaching this is significant, highly publicized triggering events. And we've certainly had those in the last couple of years. When you think back to the SolarWinds Sunburst attack, when you think about some of the open source vulnerabilities that we've experienced and the fire drills associated with Log4J, Log4Shell, we've had an increased awareness of some of the, actually malicious attacks to supply chains, as well as unintentional, or just the fact that you have 0 days and you have to deal with them. And unfortunately, we've seen that increase. If you see at the bottom, like 300% increase in attacks in 2021, and we're not doing a great job of taking care of the hygiene and patching at the pace we need to. It takes still 205 days on average to patch. So we need to tackle this issue, and we have a great set of panelists to help us do this. We want to get past the blind spots and be aware of what is available and how we can address it and incorporate this into our practices and processes, and when we acquire software, as well as when we need to respond to incidents. Because the future of supply chain risk is going to probably increase as opposed to go down. So I promised that our panelists would be able to share a bit more about their backgrounds. And if we go ahead and get started, John, if you wouldn't mind going first. and sharing a bit more about your background and the context of what you've been doing. And I know you've done quite a bit in the whole area of software supply chain security.
Yeah, I had, when I retired from the civil service in December, that was my third time in the federal government. In 2008, I was hired to implement a practice called software code quality checking. And I apologize to everyone listening in if I mention SCQC, that is the acronym for that term. And it was a concept that was developed by my good friend, the late Dr. Greg Guernsey, in which we went through and scanned code for both technical weaknesses, security weaknesses, and vulnerabilities, as well as architectural weaknesses. So we began going through and scanning. We started off by scanning the legacy Department of Defense electronic health record, and found out that the application was technically weak, filled with security weaknesses and vulnerabilities, and was architecturally unsound. Other than that, I don't have anything else bad to say about the application. But whatever it was, is we were able to go through to use that information to a follow-on effort in which we quantified exactly the technical debt that had to be corrected. And within a period of 1 year for the entire electronic legacy record, we eliminated all Department of Defense Category 1 security findings, and every single transaction that supported the application met the performance parameters. It was a lot of hard work, a lot of in-depth analysis, a lot of data that was generated to do that. And based upon that, I expanded that into several others. By the way, Stan always asks that everyone be aware how I got my nickname. I received a request to give an application and authorization to operate an ATO. At the same time, I was receiving my SCQC scans. The scan results were so bad that I sent an email back to the government project manager. I said, why don't you return the software to the vendor, tell them to do it over and to do it right for a change. Needless to say, that did not go over very well. So when I walked into a meeting a couple of days later, the program executive officer, seeing me when I came in, declared loud enough so that everyone could hear, there he is, the software angel of death. Apparently, no one had ever told the vendor to go back and to do it right again in the history of the organization. And Dr. Guernsey liked that nickname, and it stuck with me. And he referred that to me
ever since, right?
Ever since. So I've had that nickname for over a decade.
Oh,
but the key is, I've also gone through and done things like I helped NSA evaluate some tools, because NSA could not go through and do evaluations because of network issues. And we were able to go through and to evaluate, for example, OWASP dependency check, its usefulness as a tool. And we were able to demonstrate that the tool, up to a certain size limit of the code, accurately went through and identified all of the vulnerabilities. The vulnerabilities were primarily in the open source libraries, but also within shared libraries developed internally by the program office. And when I told someone else that most of the code that we were reviewing were filled with technical weaknesses, security vulnerabilities, and was flawed architecturally, that was at 90% of the code that we looked at. Now, this goes back about 11 years ago. So I mentioned that to someone the other day about discussion about open source, and he claimed that I was being too polite at the time. But basically, the idea was that I've learned over the years is that when I issue a tool to a vendor, I make sure that the contract goes through and includes supporting services. So that rather than just give them a tool, you also have the capability to teach them how to use the tool. And we also go through and we use examples of what did you do right? Well, what did the tool find that you did right, to teach them, to show them how they could take corrective action.
All right.
It's been a labor of love, and I still continue to do that, even though I am technically, quote unquote, retired.
All right. Thanks, John. Emil, would you like to go next? You have an extensive background and research in this area, right?
Yeah. So my background in the software supply chain security is that I founded the company Debricked together with some friends out of university that was recently acquired by Micro Focus and now part of the CyberS family, where we have done extensive work in the scope of supply chain security and the open source components that you're using as a company. I've been researching everything between, how do you manage open source vulnerabilities at scale in terms of knowing what you have, preventing anything further from entering your systems, and remediating and effectively fixing your vulnerabilities at scale. But there are other qualities and aspects of open source that have been come very much to light with today with 0 days and malicious attacks and other aspects of community in the open source that you're consuming as a company. So there I've been conducting a lot of research on how do you determine the health and the quality of a community and surface that to in an accurate way to developers to make support them in making the right choices on what open source to adopt as a company, because it's not only about it's become very clear in the recent events that open source is not only about vulnerabilities, but you're actually extending your organization with a bunch of contributors that you don't get to have higher.
Right. They're part of your organization sort of by default, but you don't really know who they are.
No, exactly. So so we try to build out tools to help companies surface that knowledge on the open source that they're using, where they have potential weaknesses and where they need to be on alert about potential risks in the communities that they effectively tap into.
We'll talk more about that a bit later. So that's good. Thank you. Kevin.
Hey, good day, everybody. How you doing? This is Kevin Greene. My experience in supply chain software security is around a couple of things. One is really kind of, developing, tools and capabilities with my work. My former work at the Department of Homeland Security, where I was a program manager for about 6-7 years, and really trying to push forward the state of art and the state of practice in terms of how we evaluate software for things that could go wrong in software. From there, I had a high rate of success rate, I should say, of tech transition and commercialization, which has been seen in industry with the work from one of my research programs called Hybrid Analysis Mapping, which helped influence the Gartner hype cycle around application vulnerability correlation. You see that research in some of the technologies that was developed by CodeDX, which was acquired by Synopsys, as well as Denim Group Threat Fix, which was acquired by Codefire. So the track record of taking R&D from either small business or academia and transition into the community of practice is important. I also have experiences working in MITRE at working with the CWE team and CAPEC team, as well as working on attack and doing some special things around attack and helping provide a risk management perspective from an attack and really understand here are the different types of sub-techniques and techniques that the adversaries are using. How do we mitigate this? How do we design systems, plan for systems in a way where we can have resiliency built into our overall system? And now I'm at Micro Focus, being part of a great team, really trying to help our customers build better resiliencies, not only in the applications, but also in the network and every fabric of what we do. I believe that software is so ubiquitous. It touches everything that we do. And my favorite line that I always say is, don't bug me to death. And that's literally and figuratively.
That's a good one. All right. Well, hey, before we move on, I do want to say I have a series of questions that we'll go through with the panel. But please, if you have additional questions, put them in your the question box, and we'll get to them at the end. So, John, I'd like to have you address this first question around why we're seeing such a large increase in software supply chain attacks. And part of me says, shouldn't acquirers already be aware of these risks and be vetting the software they're consuming and bringing into organizations more effectively than they are today? I mean, in that practice they should already be putting in place.
Well, let me say that taking a look at seeing what's coming out of CISA recently with a number of their reporting of vulnerabilities, that I have seen a large number of those vulnerabilities going back well over a decade ago. So the vulnerabilities that have been in the supply chain have always been there. The fact is that they were not being attacked, they were not being exposed. At a recent presentation I gave, I talked about buffer overflow when it was first identified as being a security weakness, a security vulnerability. That was 1972. The first identified attack was 1988. Well, I think things have gotten a little bit faster. We no longer have a 16-year gap between a vulnerability and someone being able to go through and to discover it. The tools allowing people to go through to find the vulnerabilities are getting far more sophisticated. And I believe that part of the problem is we are just beginning to expose the legacy of what's already out there. And that's because the adversary is getting so much smarter. I mentioned the fact that one seminar I gave for Micro Focus, that I did an analysis on an open source product that was based for recommended use by a senior political appointee. And somehow someone convinced him that when I reported 28,000 hours of technical debt, that maybe that wasn't a smart tool to go through and to use. But in those, which gets to the second part of the question, Stan, that you're going to go through and ask me, when we actually talked to the CEO of the company who owned the product, it turned out is that most of the vulnerabilities that we were reporting, he already knew were in his code, and he already knew where they came from. And he often made a statement that part of the problem why he couldn't correct things is because they were inherited weaknesses from his partners. And he couldn't go through and guarantee that his partners would correct them. So being the fact that my wife is an Italian from Brooklyn, I made the CEO of the company an offer he couldn't refuse. And that was that if his partners did not go through and fix the findings that we had reported, that I would go public with them and embarrass them. I was pleased to find in the most recent report that came out of CISA, that product, which had 28,000 hours of technical debt, there was actually one reportable exploitable weakness in the product.
That's great.
So over the years, the CEO made a commitment to fix them. But the thing about it is that he knew it. He was looking for someone to tell him, start fixing it. And I believe I was the evil impediment that helped him to go through and to fix it.
And I think that's part of the problem, right? If the acquirers, if the buyers aren't asking for a higher level of security,
yep,
you aren't going to get it.
Yeah.
Kevin, Emil, anything else you'd like to add?
I think partially, I just think that, software is everywhere, right? I mean, that's a large part of what we're seeing. Software, as I mentioned earlier, software is ubiquitous, is everywhere. And I don't think we've done a good job at practicing a very common software engineering term called software minimalism, where we are kind of reducing the amount of software that's not needed to
reduce the complexity, right?
Reduce the complexity. So I do think that's part of it. And then I think the other piece is, we have not done a good job at really understanding the technical debt that may be associated with a lot of software that is very prominent in a lot of systems that we build. And I think there's a research component to it that we really need to have some idea of like the overall defect proneness rate and the attack proneness rate associated with software, because I do think over time they eventually will eventually expose vulnerabilities that can be catastrophic. And we're starting to see some of that now with a lot of the supply chain breaches. And these are not new types of weaknesses. We are all familiar with these type of weaknesses, but we really got to figure out a way, how do we um, really manage the consumption of open source and third-party software, to the point when I say manage the consumption is that we need to have some way to kind of vet it and really do a good job at understanding what we're getting. And I think that speaks to what the great work that Alan is doing around SBOM and some other initiatives that CISA.
And that's Dr. Alan Freeman over at CISA now, right?
Right.
Yeah. So Emil, again, in the context of why are we seeing such a large increase? What's your opinion?
Yeah, I think you're making great points, but there's also one thing that that I think this is really a side effect also of the state of the world in how we need to increase the productivity of software development and developers. But in reality, the amount of actual people knowing how to code, the developers, is increasing by low single digits % each year. But the performance and output needed from those people has the need for that has increased a lot during the last decade. And open source has definitely been part of that journey to help developers get more functionality out to customers. And I think this new attack surface, or not new, but more exposed attack surface, has become larger and larger, where we have seen, the average saturation of open source in a company, in an industrial code base, has gone from 30-40% to 80-85-90%
Right.
in a lot of companies. And you're not pulling in first level dependencies, you're pulling in a depth of 30 in the transitive layers of the dependencies, and this creates new types of complexities that were not that did not expose this surface in the same way 10 years ago.
Yeah. So again, the recognition that modern development day is very comfortable with and has to reuse software. And open source software is one of the great examples of how they reuse, and it's 80 to 90% of applications could be open source.
I always say more complexity means more code, and more code means more problems.
Yeah.
Yeah, Stan, one of the issues on open source is the fact that for 4 years, there's been a DoD policy, for example, that says before you use an open source library, you have to go through and to do a full software assurance analysis of the library. And I've asked people who's doing it.
Yeah.
Yeah, and fortunately, the people who work for me, who I did IB&B for, I made them do it. And again, I'm finding, a cost about how does it take. There appears to be some consensus on the web that it's about 3 months into a development process using a new tool that developers really become comfortable, and it almost becomes second nature for them to automatically run the tool and to recognize that they've done something wrong. And I think part of the problem, we're not communicating effectively the learning time it takes to go through the ramp up in order to prevent these downstream issues from being discovered after the fact. And I did an economic analysis and have a business case that goes through and proves that the time spent investing in doing things right more than adequately pays off for not having to fix something after it goes into production.
Life cycle. So, it's a good segue to, this question, Emil. I'd like you to take it first is, again, these unintentional insider threats through the use of vulnerable open source software. It really is a challenge, and of course, it's not necessarily the developer's fault, but what do you see as some of the practices they can put in place to mitigate this?
Yeah, so I think it's usually how we think about ourselves as the Brict is that our job is to solve this challenge by not disrupting the developer and making it as easy for them as possible. And as you said, John, trying to become second nature to the developers as soon as possible in terms of the framework of knowing, preventing, and fixing your vulnerabilities. So I think first of all, knowing is simply scanning for your open source software that you're using. There are great new there's I think the software bill of materials through the Biden order have gained a lot of traction, and it has seen some growth in the past year of its adoption. And I think that's a great start to know what open source you're using and know what
just and if you can share what that is, what is a SBOM? What does it do for you?
So an SBOM is the standardized way of where you can and how you identify what software you're using within your software. So it's a bill of materials where the materials can be vendor software, but most commonly it's the open source software that you consume in an application.
So it gives me the visibility as to what's going on in that application or that software package.
Exactly, and ideally you want the SBOM to also include transitive dependencies, and so you gain transparency in your full dependency tree and all the software that's executing on your servers in the end. So SBOM is a standard way of and becomes a file in the end that specifies the open source that you're using. So today there are two competing standards. One is CycloneDX and one is SPDX. They do have their pros and cons, but CycloneDX, to my opinion, has the most mature way of communicating vulnerability information within the SBOM file as well.
Can you distinguish what the value or what an SBOM gives you versus what software composition analysis provides?
So, software composition analysis is the task of analyzing your software and the dependencies you bring into that software. But an SBOM gives you a way to communicate the results from software composition analysis outwards, or even analyze your vendors' SBOMs. So we're seeing the tools pop up and the abilities within software composition analysis where you can take your vendor SBOMs and scan those continuously for vulnerabilities as well. So when we are using products from our vendors, such as Elasticsearch, we can rely on their vulnerability reports, but we can scan their SBOMs as well.
Great. John, Kevin, anything else you want to add?
The only thing that I've become aware of recently with my discussion with Bob Martin from MITRE is the fact is that in some of the problems he's seeing with people reporting their SBOMs is that they may be overcomplicating things a little bit. In other words, they're grabbing an open source code and maybe only using 10% of it. The code may have, say, like 10 components, they're using only one. They're getting a report that identifies all of the vulnerabilities. So they go out trying to fix everything that's wrong, only realizing that perhaps only 10% of the findings actually pertain to them. So there's some way of racking and stacking and prioritizing the work. So it's not just to know the full package, but to know the individual components within the packages that you're using so that you know whether something really needs to be fixed or something can be deferred or mitigated through another other activity. Okay.
Good observation, Kevin.
One last thing, I just think, and I think Emil kind of touched on it, is I think developer advocacy is very important in such a way that we gotta, whatever we do, we have to create the ability to have workflows that integrate security as part of their daily task so that they can fully understand what could go wrong and what will go wrong, but also give them an understanding of potential threats that they should be aware of, right? We have to just do a better job of just, advocating for developers and providing tools that integrates into what they're normally used to, and so they can educate them and help them be better.
And Kevin, that's a good segue to the next question, man. So what are some of the tactics and techniques that external attackers are using to sort of subvert the software supply chain, and what are some of the focuses that you think are should be priority for these cyber supply chain risk management programs to help mitigate things more holistically?
So we've seen everything from malicious software being embedded into hardware. We've seen with the SolarWinds, the build environment was compromised, the update infrastructure was compromised, and we're starting to see more now of stolen certificates, right? Code signing certificates. We're starting to see more of that, and actually also imposters where you think it's a legitimate company, but it's not. So we're starting to see a lot of different things. And the other thing is the manipulation of a code repo, right? You know, you want to go after a code repo, you can compromise that, attack that to affect the supply chain in a very, very systemic way. In terms of like strategies for combating that, I just think that one of the things, not one of the things, but a couple of things we should do is we really have to be aware of what we're doing from a cyber resiliency standpoint and build better resiliency into our software deployment and delivery process. And I touched upon earlier the whole concept of software minimalism, where we're reducing the attack surface, we're not using code that's not needed, we're deprecating things that we're not using in terms of endpoints and so forth and so on. We have to formalize a process to vet software, right? And a lot of times we can't just use one testing technique because the attack vector, the threat actor, a lot of complexity in terms of some of these attacks. So we have to use a combination of different things, but we have to automate it. So we got to use SAS, DAS, pen testing, threat modeling. All these capabilities have to be used in a way where we can really get some insight into potential attacks that may be associated with software. And the other thing I would say in terms of some of the things we can do to focus on supply chain risk strategies is we have to patch on time. We have to patch on time, and we need to bolster our incident response, right? Because we do know a couple of things are happening. The time to exploit is shrinking, but we also see that the time to patch is sliding further right. So I saw
205 is
right.
just too many days.
Right,
Yes.
right. And the other piece in terms of that is trying to leverage better analytics to get visibility from a security operations standpoint, so that the dwell time, if their attack does happen, the dwell time is not long. So those are some of the things that comes to mind for me.
Yeah, and just going back to your code repo example, I mean, I think I'm starting to see again organizations create their own internal code repo of trusted code that the developers can ingest in the development process, right? There is that process of what do you do to, if you may get a request, but there should be a vetting, right, of that software prior to then developers using it and getting that in place so that you're not willy-nilly introducing by just going out to any other external, potentially compromised code repo.
Trust is very important. Having trust and ability to attest to that is very important.
Yeah. John, Emil, anything you'd like to add?
Well, many years ago, to show you how old I am, in the early 1990s, I was doing some work with the National Security Agency. And one of the things that one of their lead cyber experts at the time said, you have to assume that the bad guy is already in your code. So just make that assumption that they're already there and they're waiting for you to do something wrong so they can exploit your incorrect action. So recently I was on another webinar in which somebody went through and took a look at some code. They did an analysis with a tool like Fortify, make sure that everything was done correctly. But then they actually went down into the registry and found that there were 10 components in this huge enterprise application that nobody knew why they were there. And it turns out that they were the names associated with certain ransomware attacks. So the code was in the system, sitting there, waiting to be exploited. So recently OWASP came out and said, look, you've got to go through and do static analysis, dynamic analysis. You've got to go through and fix them. But if all you do is address the OWASP top 10, you're only getting at 55% of the problem. And see, that's part of the difficulty that I see, and other people tell me, people believe that when you do with a scan like Fortify and Web Inspect, that you've solved the problem. You've solved 55% of the problem. The other 45% are APIs, code that looks awfully good, but really shouldn't be there. And so we are not, I don't think we're making everyone aware of all of the implications of everything that needs to be done. But this particular question that you have up here, Stan, one of the ways that they're subverting supply chain is, let's say, Log4J, for example, that will become very well known. Everyone's doing that. Somebody raised the issue. Well, what happens if Log4J is a smokescreen to hide something that's actually more serious? And nobody wanted to hear that question. All right. So are the attackers going through and letting certain attacks become visible, getting us to focus our resources on solving them?
Time, watch the hand over here, but then
yes, that's right. Yeah, like the Wizard of Oz. So don't pay attention to the man behind the curtain, that there are other more serious things that really need to be addressed.
Right. Emil, what's your opinion on this?
Yeah, I think I agree with you guys. It's I think there are potential smoke screens here as well, because the fact that it takes about 800 days to discover an open source vulnerability in a project from the code, the vulnerable code was actually committed to the project. And those 800 days is way too long, and most of the vulnerabilities are not actually disclosed openly today as well. There are silent security patches. So it's hard as an organization to know exactly what vulnerable code is potentially executing. But for adversaries and malicious actors, this creating these smoke screens or simply exploiting things that they know that you don't know is a factor here. So I think as the state is today, in the industry has a knowledge disadvantage where we need to build better behavior within the community and a lot more automation and capability of our tools that we're building out to really tend to the developers and not add extra work to them by powerful automations.
No, and speaking of community, I mean, you mentioned this earlier, the value of understanding the community that is actually creating your open source packages that you're consuming, right? And so maybe you can expand on some of the characteristics that you think are important to look at in a community to help you make a better risk decision.
I think time has proved again that continuous maintenance is important for the community. We have the Heartbleed attack where the community they did solve that 0 day, but the project was regarded as done when the vulnerability was discovered. So and speaking to the fact that it takes about 800 days to discover vulnerable code in open source, and quoting Linus Torvalds, with the rule of many eyes, all bugs are shallow. So discovering these deeply nested security flaws within our open source projects is going to be a challenge throughout, and we can't rely on humans being perfect when developing their software. So I think looking at a couple of different aspects of the open source communities, we have health metrics for that in an open tool it's called Open Source Select. If you search for that, you can look at these metrics. But there are some key factors that correlate with good security practices, such as looking at how they merge pull requests. If you continuously merge non-peer review pull requests that have above about 350 lines of code, the bug saturation in that code goes through the roof.
Yeah.
And there's also the fact of truck factor, where about 14% of the most popular packages on GitHub have went unmaintained for a year. And that is because there's been too few maintainers actually maintaining that code. So there is one step where we are as an industry, that we need to know the quality and the community health of the open source we're consuming, but we're soon, to a larger extent, going to need to step in and actually help the community to maintain these projects as well. We have some companies doing great work here, such as Google and VMware, but this needs to become largely more adopted in the industry to let your engineers maintain and contribute. And
I mean, Google just came out with an announcement, right? What was it? I mean, a very large investment that they're helping to help secure some of these open source projects, right?
Yeah, definitely. Yeah, they did. So, and creating a role, a curator role, where they will have funded people helping maintainers to secure the projects.
Right.
Yeah.
In fact, Stan, I'm probably going to get the acronym wrong, but I got an email recently from, I believe it was the Open Source Software Foundation, OSSF, in which they recommended that people leave GitHub.
Yeah, I saw that too. Yeah.
No, that doesn't get people's attention. But a year ago, when I participated in 2 years ago, when I participated in a workshop with NIST, one of the members of the panel indicated that there had been a study done and found out that 30% of the people who were developing open source code and providing it free didn't care of whether the code was technically weak or had security vulnerabilities. They were focused simply on functionality. And you could scan the code and find that. So I had a report provided to me by a friend of mine that came from the United Kingdom, in which they went through and took a look at a product that had suspected backdoors to feed information to another country that shall be named. But the source code was so bad that they were spending all their time trying to go through to figure out how to fix the source code, and completely missed the fact that the badness of the source code was hiding all of the backdoors. Okay, so you just have to go through and to make an assumption that if you're fixing one problem, you might very well be missing something more important.
Good point. Good point.
I'm glad I'm spread the happiness and joy with all of my comments today.
Well,
I can add a fun fact to obfuscating code in a malicious attack.
Yes.
It's a common way to just add a couple of hundred new lines and just put your malicious code at the end of a very, very long file, so you developers or viewers don't simply scroll down to the bottom.
Yes.
There's been a few cases of that type of obfuscation.
So Kevin, this question is for you in this context of, there are a number of threats, and having that awareness of what is actually being used can help you in the defensive side of the equation, right? So how do you believe that you can leverage threat intelligence to help better inform what activities you perform in your processes to mitigate this risk?
So I think we have to figure out a way to codify the things that we know about how the supply chain is being attacked into our daily practices, right? And use that threat intel to inform us about our software construction process, like knowing what threats are likely associated with certain components, right? And being able to use that information to better design and build in resiliency and security, right? So if we have idea of how the supply chain is being attacked and how software is being attacked, I think we should be able to design and implement better security or compensate controls into the overall design of the system. Knowing what ingredients and components that are being used for software, it gives me an understanding of like, hey, if I have threat intelligence about a certain component, and not only there's things in a while from a vulnerability perspective, but there are threats from an adversary perspective in terms of malicious software or malicious code that may be associated with it. The other thing is understanding like what software packages are known to be more maintenance prone than others, right? And being able to make informed decisions about, hey, is this piece of software or this component something that we should use in our environment? And I think having a way to leverage some threat intel to inform our security operations teams and hunt teams so they know what to go after and what to look for.
What to monitor for, right?
Exactly. That is a way to kind of calibrate that into their daily activity. So I need to be able to understand when I go and select a certain component, or if I receive a as part of the procurement process, I receive software from a supplier, I need to have some way to leverage my threat intelligence to inform me about the software that I'm getting, to make better decisions that, hey, we need to make sure that certain controls are built into our environment, our infrastructure, because we've noticed that certain things we're seeing activities about co-signing issues with certificates or update infrastructure being compromised. And these are the types of software components that are being targeted. I think all that is very helpful in kind of understanding how to, we look at resiliency, adapt to some of the adversary
Right.
activity that we see with threat intelligence.
Emil, any opinions on that?
Yeah, I think I'm gonna go back to my last point, that knowing what you have and the quality of that is going to be a more vital part in the software supply chain, and understanding what communities you tap into and what the practices are within those communities. Not all open source use automated testing, and you're definitely using that some of those open source projects. Do you want to, when you have that practice as a requirement internally? Just bringing that intel up to the developers is going to be vital, and then also like looking at the new attack surfaces. That's not only from the trends in the supply chain, but also with Corona and working from home, where you may not be able to protect your developers' laptops with good firewalls, and a lot of these malicious packages are able to extract environment variables and keys from your developer working stations that they have at home just by installing a pip or a node package. And that's the most common way actually that malicious actors are trying to inject malicious code into these communities.
Interesting. So John, I'm going to have you've already mentioned some of the materials out there that can help the industry respond. But as far as helping our participants know some of the resources out there that can go to help respond to these mandates that are going to be coming out from either their customers or the governments. Anything you'd like to highlight or put a spotlight on in addition to what you've already mentioned?
Yeah, well, about 2 months ago, I was asked to take a look at how CISA, and for those of you who are not familiar with, that is the Department of Homeland Security, Cybersecurity and Infrastructure Security Agency. And they have a catalog of services that they offer. And I was participating in another meeting in which, as a CISA representative was there, the government raised a particular question. The CISA rep immediately responded, in our catalog of services, we offer the capability to do such and such. So the only questions that I had to raise is, because I've been familiar with catalog of services, is are they funded to go and staff to go through to provide all of those services? I thought there was a laundry list of things that they could go through and do. The other thing that I want to go through, and I've recommended, and I made my tool vendors do when I was in the government, that if I was purchasing a tool, I also had to purchase services, consulting services. And I wanted to be able to go back and to reach out that if I had a problem or if I wanted to use the tool in a slightly different way, I would have an expert that I could turn to in the company that provided me the tool. Now, I had exactly the opposite experience with working in the government, in which a government agency said, we don't need that because we can just look at the tool and read the documentation and figure out how to solve it ourselves. Needless to say, that was a disaster. So basically, there's what needs to be done is that for those of us who are on the selling of mechanisms to help us to identify issues with the cyber supply chain, we also have to tell our consumers, you also should have at least in the contract, a services capability, so you could turn to us when you encounter something that you don't understand. Okay, now I want to go back to my archaic, someone call it Jurassic experience in Europe, in which I was the operations officer of a division signal battalion and worked with the German signal battalion. The German army had a very unique way of doing business at that time. This is back in the 1970s. And they went through and reinforced all of the basic principles every 90 days. And their assumption was that if you do all of the basics right, you can address 95% of the things that are going to show up on the battlefield. You have the time to address the other 5% because you're not worrying about the 95%. I find it stunning that we still have code that is being produced today that has SQL injections. I find it absolutely stunning. I mean, we should have a federal law in the United States that says there shall never be another SQL, another code injection. Now, if you can get that off the table and you're not worrying about that anymore, you can take those resources and devote them to the 5% things that you didn't anticipate or didn't expect.
It's a real challenge, right?
And that was the whole basis of what I was trying to do when I was in the government, to tell people to go through to just fix the simple things, okay, and to seek advice as to how to go through and to do that. Now, so that when the things that you didn't expect to show up, you have the resources to address them, because those can be a lot more troublesome. Gotcha. Such as a new vulnerability that pops up that you had not previously planned for.
Right.
So the services have to accompany the tool. Okay. And using my experience of my son, who's a CPA, he goes in and he believes that when he does his initial engagement with a company, he spends a lot of his time teaching people to how to go through and to repeat what he just went through and did for them, so he doesn't have to come back the following year and do it all over again. So there's got to be the tools, how to use them, and how to develop the internal expertise. I've seen multiple red teams, companies come and give presentations in which that's their modus operandi. We go in, we do a penetration test, we show you how we red team, we assist you to set up your purple team.
Right.
Those are the type of things that we have to go through and to help companies. And then the business case that shows you why the cost of investing in those capabilities, the return on investment is significant in terms of the things that you don't have to fix on that 205-day to fix something in production.
Right.
What's your ROI? What's your payback?
I do think that design is also an important piece to it. Well, a poor design is almost certainly going to expose an attack surface if we're not aware of how to build design principles, right? Design thinking into everything from the early parts of the software construction process into procurement, all the way through the whole life cycle. We gotta really get back to good design principles that enforces resiliency, that enforces security. And the other piece is quality. Quality is an important piece because it touches upon security. There's a very distinct relationship between quality and security. And if code doesn't have quality, if we don't have good design, right, then we need to take that design and have code implement those design tactics properly. If a developer is not fully aware of what the design is and how to implement design correctly in code, then we will never achieve the initial design. We will always have issues or vulnerabilities, or I should say weaknesses, that can expose vulnerabilities in software. So
there's some really good guidance out there for folks to how they can think about the principles. I mean, whether it be from NIST or the 800-160 security engineering. There's a whole bunch of books out there. I mean, so there's a lot of guidance on how you can do this right. Emil, anything else you'd like to add to this?
Yeah, I think that I think there's been a lot of work great work being done by institutions and organizations here with the Biden order, and we have the SASA framework that came out recently.
Right.
We have some strong organizations that have reached higher levels of SASA. I think VMware reached SASA level 4 recently, and that's a big thing. So looking at those different frameworks to understand where you stand as an organization, and being able to tap into the shared knowledge that the industry is creating through these foundations, such as OpenSSF.
Right.
Because there is, it's hard to, since the attack surface is so new, and frankly, there is no one tool that solves everything today. So you need to create a holistic view of what your needs are, and how the industry and government and these different frameworks best suit you as an organization.
Stan, the big thing about everything we've said is go back to what I've said to you. It's got to be written in the contract. Because if it is written in the contract, every vendor that I've ever worked with over the past 15 years, if it's written in the contract, they've come back and told me, and it's written well enough that they can go through and cost it out and submit a reasonable cost proposal. Okay, and once they go through and do that, and you agree to go through and to fund it, okay, then they will go through and begin to see the return on investment. I also noticed Kevin had a point. We sort of rambled all over the place, but I really saw the use of threat models, okay, and particularly the just the primitive use of a data flow diagram to make people to understand their design and where the importance of the security weaknesses that we were reporting, where they fit in, and why some were more important than others. So to have a requirement to do, you will comply with the framework. The vendor will cost it out. You will produce threat models. The vendor will cost it out. Okay, and they've all said that they can do it, and they get upset when these things are not included in the contract.
Right.
Because
you don't ask for it, they're not going to do it.
Yes,
So,
because they don't believe that they have the mechanism to submit an appropriate cost to the government for performing the task, for performing the work.
so I just checked. We don't have any questions in from the audience. I think we've covered the issues quite well. I just want to wrap things up, again, without getting a lot of detail at the end of this webinar. We do have a portfolio that addresses a lot of this. Again, Emil, thank you for your work at Debricked, but Fortify does enable you to build software with resilience for modern development. We have a 10-year partnership, our 10-year long industry leading partner that you can work with. We do static, SCA, dynamic, across the board. You can learn a lot more if you check out our YouTube channel. It's Fortify Unplugged. A lot of videos out there, and I think we're going to get some new ones posted on Debricked as well. I believe that's coming. And finally, we do have a couple more webinars lined up for this series. We have one later in July on API security. And then again, one of the things that's always a challenge is being able to scale up your application security program to be able to meet the needs and the inventory that you have in your organization. So please look for those and register for those. And again, really appreciate your time today with us. I want to thank our panelists for their insights and their knowledge and great interaction. And again, please look for these upcoming webinars, and we'll be posting to you as well the recording if you need to look at it later. Thank you, everybody. And again, thank you, guys.
Thank you.
Thank you.
Thank you very much.